Hey, hi there YouTube, and welcome to my third lesson about vectors. This video is not going to be about finding the different vectors, because we covered that mainly on the second video. But this video is going to teach you about some problems which you might, or some questions which you might come across in your exams. I know they do in the GCSE papers, but in some of the questions they will ask you for a couple of proofs for vectors, and these proofs might have a triangle or a quadrilateral, and ask you to find two vectors, and then they will ask you to prove that these two vectors are, for example, on the same line, or that they are parallel. And I've got these two vectors here. One is the vector x, and the second one below it is vector 1.5x. They're both the same vector, apart from the fact that the second vector here is 50% larger, and I haven't drawn it very accurately, but this is the best parallel line I could really get, and I know it's not really 50% larger, it should more be out there. But anyway, how do we know that these two vectors are actually parallel? Well, quite simply, it's because they factor into each other. They are, how can I describe it? So say you have a vector here, 2a plus b. If, say for example, I had 4a plus 2b, they are, the smaller one is a factor of the larger one. It's a factor by 2. I mean, if you multiply this one by 2 and that by 2, you get this one. And the reason they're parallel is because they are essentially the same vector, just a different length. So when you're asked to find, or asked to prove a vector is the same, is parallel to one another, you have to prove that the two vectors are factors of each other. And you can do that simply by just saying, call this vector A, call this line A, and call this line B. You could say line A is a multiple of line B, so line A is a factor of line B, so they must be parallel. I mean, that's all you have to say. And then the next problem which you might occur is whether the vectors are on the same line. And essentially, if I just draw a line, let me draw 3. Oh, you can see that. Yeah, you can see that's fine. You draw say you have a line with 3 points on, and from line A to B and B to C, they're all vectors of x, and you can say vector x, well, vector AB is on the same line as vector BC, because the vector is the same as the previous vector, because they're all along the same line, so it has to have the same vector, and here they do. Obviously you're not going to write it like that, but that's just a way of saying it in real life. I mean, obviously you word it differently for your test. I'm just going to pause this video now, and I'm going to create a more complex problem where you have to find out a vector and draw the vector on the shape, and then on that shape you have to prove why line A is parallel to line B. See you then. Okay, welcome back YouTube, and here I have this question which I promised you. This question is split into two parts. If you cannot read the writing, I'd suggest you go into full 720p HD and switch to full screen, and you should be able to read it. But anyway, I'll explain the question for you. We have to find and you can, if you want, draw the vector from D to E. So what's D to E? Well, I'm not sure if you can read this, but E is 2/3 along. That should be C to A. Thirds along C to A. And we have D here, which is at midpoint of BC. So what we have to do is find the vector if we want to get from D to E. So we'd have to express that in terms in using X and Y. And A to B is X, and A to C is Y. And the second part of the question, we have to prove that this line, this vector, is parallel to AB. So I'd recommend pausing this video and having a go at this video yourself to see if you can work it out. I mean, if you've been watching my previous videos and the start of this video, which I presume you have, you should be able to work it out with a bit of thought, but it should be possible. So anyway, how are we going to approach it? Well, first of all, we're going to have to work out how we are going to get from D to E. And what I'm going to do is I'm going to go from D to C. So I'll have to work out what D to C is, and then from C to E is. So to get that, first of all, I have to find out what D to C is, and I have to find out the vector of this is. So what's the vector from B to C? Well, to get from B, we have to go negative X, we're going in the opposite direction, and then we have to go along Y in the positive direction because we're going from A to C. So if I just write down actually B to C, and that's simply Y minus X, because we're going X minus X, Y. And now we have to half this because we're at the midpoint to get from D to C. It's half the distance, so it's half times Y minus X. I mean, if you're unsure about this, watch my previous video and I do explain it in hopefully some good detail. And the next stage of the problem, I have to get from C to E. And I already know what C to A is, that's minus Y. And this is 2/3 along, so it's 2/3 or minus 2/3 Y. So now I've got my two equations, or expressions. I've got D to C, and now I've got C to E. I'll just move slightly. So now I have to add them up and form one expression, and this will be very useful when working it out in terms of X. I think this is going to work. I hope this is going to work exactly. So what do we have? I'm going to multiply out the brackets, so half of positive Y, take away half of X, and then we add, so minus 2/3 Y added to half of Y. So in order to break this down into a single Y, we're going to have to add them. Sorry, take them away, because this is a negative. So I need to get the denominator the same, so I'm just going to do 3 by 2. If you're unsure on adding, multiplying and dividing all those operations and fractions, I will be releasing a video about that soon. So stay tuned and subscribe. So what I'm going to do is multiply together, so I get 6. So I'm just working upwards here. So I've multiplied this by 3, so I'm going to multiply the top by 3. And then I multiplied this by 2. Oops. So I take them away, so minus, plus. I mean, if I swap them around it'll look more logical, but that's going to equal 1/6 y, take away half of x. So actually, in fact, this was a trick question. So in order to get from D to E, you'd actually have to go upwards a bit. It will not be exactly parallel, and that is because you've got some only very small, but you've got some sorry about that, my camera ran out of memory. I have got a new memory card on order from Amazon, a 32GB one, so it will last a lot longer than my tiny 2GB one at the moment, I'm ashamed to say. But anyway, what I was saying that that because it's got a slight vector y in, it is not going to be exactly straight, because y goes upwards. And you can say this in the proof. You can say in the proof that the two vectors are not parallel, because vector x is not a factor of vector DE, and that's because they do not divide into each other. There's not a common factor which multiplies one of them into the other. So anyway, that's just a example question of what you may get in your exam. I hope this helped, and I hope this explained to you a bit more about parallel lines and how you will explain them in the exam as evidence, because nowadays in exams they will ask why you think this, so if you get the wrong answer you get merit for doing the right method. But anyway, that's my video. I thank you for watching the video. If you have any questions or suggestions, or even if you really enjoyed or learnt a lot by watching this video, please leave some feedback, and of course if you learnt something, please like and subscribe to my channel. I'd really appreciate it. Thank you for watching, and goodbye.